can write down somewhere, because this is the equations that you're going to use. This guy m is essentially the mass of the whole object, and it's a double integral of d of a function called rho of xy. Rho, pronounced it like the word rho, R-H-O is a Greek thing. Looks a bit like a P, but it isn't a P, right? Rho of xy is called the density function. And what the density function does is it tells you how heavy, for want of a layman's term, the object is at any given point xy. So you can imagine you could have a rectangular plate, but it was made in such a way that it was heavier on the right-hand side and not in the left. And it graduated down. Tim?
I've actually seen this used in real life. We actually use this at my work, because when you pick something up with a crane, you don't want it to swing. And so you have to know where the center of gravity is, and you have to make the measurements from the point you're picking it up at all equal distance so that you support the center of gravity. So when you pick it up, it just comes straight up.
There you go, guys.
Straight down.
There you go.
And they cut submarines in just weird banana-shaped chunks, and somebody will go down there and calculate the center of gravity in 3 dimensions with a calculator and paper. I'm not kidding.
Yeah, Rosie, you got something to say?
Oh, I was just like doing the hand clap emoji reaction.
Oh, you were doing not the hand up, you were saying, "Hey, we can use it."
Yeah.
Isn't it? I think what's happening here very slowly is that as we move up the math food chain, can't you begin to see, oh, you could actually use this in a real life context rather than, I don't know. When would you ever want to factor something, right? Something that's a little bit esoteric. Now, this particular one is for 2-dimensional objects, right? So m is the mass, which is basically the double integral of the density function over d. And d is the region, the disk, that you're going to try and find the center of mass on. And we've got this guy called moments. The moment of y is the double integral of x times the density function. M of what x is the double integral of y with the density function. Rather unusual name. You would have thought that should be called mx and my, but they're not, right? And x bar, the x coordinate, is the moment round y of m, and y bar is the moment round x of m. So basically, if you wanted to find x bar, wouldn't you find this number and divide it by that number? If you wanted to know y bar, you would take this number and divide it by that one. Now, we're only going to do double integrals, which are 2-dimensional ones. But if you are interested, let's talk a little, just for a few moments, about 3-dimensional, and then you'll actually get to see them in the future when we do triple integrals. So in a typical, so this is for essentially a flat piece of paper, right? A lamina is what they call it, right? It's a bit like a piece of metal, right? It's not got much thickness, it's mostly area. But if you move on to 3-dimensional objects, like the center of mass of a peanut, right? Or some blob that was banana shaped, like Tim was saying, then the mass is the triple integral over the region, I'll call it R. And the density function now will have 3 variables in it. And when you do 3 variables, you call that guy dV. So you can imagine on this solid 3-dimensional object that it could be heavier at the top right-hand corner, lighter in the center, and so on, right? It's got all sorts of things going on. And then you have the moments, and they are given very specific names. They are called xy, xz, and yz. And they are triple integrals as well. And the one that's called xy, right, like this is y, has a z in it. And the one that's called xz has a y in it. Do you see the symmetry of how this is?
So you're always putting in the variable that you're not calculating, that you're not finding based on. Oh, that makes sense, because then you can find it based on the position of the other two.
Yes. And so you want to find x bar, you use this one. You want to find y bar, you use this one. And you want to find z bar, you use this one. And that would get you the center of mass and 3. Now, you could do 4 dimensions. I have no idea who would do it, but I guess people who do theoretical physics and think of space-time as 4 dimensions, they could do that. Can you imagine you would just have X, Y, Z, and T, right? X, Y, Z, T, right? 3 positions in one time. So you could do 4 of these guys, right? The one that was missing would go here. And then you'd have an X bar, a Y bar, a Z bar, and a T bar. And you could talk about the center of mass of a 4th dimensional object. God, that would hurt your brain. So, I mean, there's no limit to it. But back to what we're doing. We're only going to do 2 dimension. And that means a lot of double integrals. And where's my question? I had it somewhere. Oh, here we go. Question that we're going to do is from the homework, if I can find it. I know I did it, or at least I started to do it last time, didn't I? And then we ran out of time. So I'm just going to kind of continue from there. I believe it was question 2. It was. Now in question 2, the density function was x cubed. So that's essentially, you know, the guy that's going to go here, right? And the region D was a basic rectangle that looks something like this: 0 to 1, 0 to 1. So I'm going to set this thing up right now. I've already got my density function, so that's good. The range of x's is going to be 0 to 1, and the range of y's is going to be 0 to 1. Would you agree that this information is going to work really fine with x's and y's? Now, if this was a circle or a bit of a circle, wouldn't I be thinking they turn it into polar? Just because that would be easier to deal with. And most of them are, from what I've only scanned through them, but most of them tend to be of this type, right? But there is, I know there is, because I did see at least one that was polar. So you begin by finding essentially the mass of this object. What would that whole thing weigh if this was its density function? Well, it's going to be a double integral of x cubed, and we're going to do x equals 0 to x equals 1, and y equals 0 to y equals 1. And the order I've decided to do it is x and y, right? Can you separate these guys? Can they be separated? Great. So if you separate them, won't you have 0 to 1 of 1 dy and 0 to 1 of x cubed dx? Right. If you do enough number versions as I have here, do you know you can tell the answer without doing any integration at all? Would you agree that's 1? And if it's 0 to pi, it's pi, right? So that's 1. This is going to be 1/4 x to the 4 evaluated at 0 and evaluated at 1, but that ends up being 1/4. So we now know m. Right, now let's do a guessing game. If this object had an equal density everywhere, right? So it was just as dense here as it was in the middle. If it was a plane density function equals 5, right? Wouldn't you agree that the center of mass would be bang in the center, right, where the diagonals cross? So it should be a half comma half. But doesn't this have a density function that depends mostly on your x coordinate? So won't it be very light at the end and then get denser to the end? So my prediction is that it's going to be somewhere about there. And my prediction is it's going to be something comma a half. Why am I still keeping the y value in the same place? And it's only the x that is going to be bigger. Tim?
Because our function of density doesn't affect the y, it does affect the x. So if you had something like x squared y cubed, then you would expect it to move up.
Up and right at the same time, right? So let's see if my prediction is correct. So these are long questions, by the way. So bear with me. I'm going to get the moment around the y's, which is the same double integral as before, 0, 1, 0, 1. But you're going to introduce a y, so what's that going to be? Y times x squared. But that separates agreed.
Is it supposed to be
And
y x cubed?
it should be. Now, since I've already found that, can I just stick in a quarter? Because you're going to probably use it again. Right, what about this guy? Let's try this guy in your head. Isn't it a half y squared? And it's going to end up being a half. So that guy's an eighth. Okay, so we got the overall mass is a quarter. The moments around the y are an eighth. The moments around the x's is basically question.
Why did we put so the integral that we just did? If we were trying to find the mass of y, wouldn't we multiply it by x instead of
It's not the mass of y. It's a moment around y.
the moment around y? Okay.
Yeah, but it was the moment of
shouldn't it
y
still
was
be?
x times the function.
Oh, so the moment of y is x times the function. Yeah. Well caught. Well, I can fix that. So what's the moment around the y going to be? That is y. We've just found. What is this one? This is the one I've just found is the moments around x. I'm now about to find the moments around y, and the moments around y are x cubed, dx, dy. Okay, I got those darn things switched round. My apologies. So we've just found the moments around x because x's get you y's. Do you see how easy it is to get those darn things back to front? Right, this guy, the moment around the y is going to be x times that fella. So it's going to be basically this one, which I can split. This guy ends up being 1. This guy ends up being a fifth. So the answer to this one is 1/5. So I know the total mass. I got that right. It's a quarter. After fixing it, the moment around the x's ended up being 1/8. After fixing it, the moment around the y's is 1/5. So far good. So far so good. Right. X bar is going to be the moments around the y divided by the mass. It's going to be 1/5 divided by 1/4, which ends up being 1/5 times 4. So it ends up being 4/5. And the y bar is the moments around the x divided by the total mass. And that's going to be 1/8 divided by 1/4, 1/8 times 4. There we go, it's a half. And so our center of mass is 1/2, 4/5. Did that match our prediction? No,
Yes.
it did. Right, it shifted. Where did it shift? No, it shifted y's.
It didn't shift anything. You just said it in the wrong order.
Oh. God, I'm bad today, aren't I? Yes, it's the right answer. I wrote them down in the wrong order. God, that was an easy fix. Which makes sense because didn't I say that it would be a little bit to the right? So you can imagine that would be at 4/5 and this would still be at half. Are we good so far with that? Right. Let me slow down. That's one of the reasons I make mistakes. Now, in this question, the region D is described as the x's are from 1 to 4. and the y's are from 1 to 2. And the density function has an added issue. The density function is some multiple of y squared, k times y squared. So it could be 2y squared, it could be 55y squared, right? It's always going to be positive because a density function measures weight, right? Mass. Now, draw a little picture of what that guy looks like. X equals 1 to 4. Y equals 1 to 2. Would you agree we've got a little triangular plate floating in space? Yes, Sam.
Will it always be positive? Because you could have a shape that exists underneath an axis, and it could be negative.
Well, the shapes that we are dealing with are two-dimensional objects that exist in real space.
Okay.
So they're going to be positive. And the density function is a real physical property of objects. In other words, objects, unless they change the rules of physics, always have positive densities, right?
Oh, that makes sense.
Zero density means
It's
I guess
nothing.
it's not there, right? That's the
Vacuum,
word.
yeah.
So
And a negative density, if you can create negative density matter, NASA would like to talk to you because you've created faster than light travel.
so I have a career if I can figure out how to do it. That
We'll just put a
doesn't.
negative sign in the integral, and it'll be fine. And
Yeah,
there
are
you
you
go.
saying I can get paid millions of dollars for doing math wrong?
Because that's the only way I would get that to work, by doing math wrong. So the double integral over this region, so it's going to be x equals 1 to 4, and y is going to be 1 to 2, right? And the density function is ky squared. In this particular order, I'm doing that. And again, we kind of got lucky here. It doesn't really matter who I give the k to be honest. So how about this? Couldn't I give the k to the x's and just leave the y squareds on its own? Couldn't I give this ky squared and just call that 1? Wouldn't that equally work? Can you trust me, both of those work, right? So you might say, why did you give the k to the x's? I just felt like it. Couldn't have called this 1dx and called this ky squared, and it would have been the exact same answer. So in this case, you're going to get 3k eventually. You can check that out. And in this case, you're going to get 1/3 y cubed, which is a third, is 8/3, take away 1/3. So I believe that is 7/3. And you put this package together and you got 7k. Are we good with that? Right. Now, in case you're worried that the coordinate of the center of mass is going to be 2/3 k, 5/3 k, and how can you plot a point when there's a k and you don't know what the k is? That k is going to disappear. Almost like magic, but it will always disappear. So, got my good guys in front of me this time, so I'll try and be careful. The moment around y is our double integral, right? Our 1 to 4 and our 1 to 2 of x times this guy. I'm going to split that as 1 to 4 kx dx times 1 to 2 y squared dy. Are you comfortable or happy about the split? Right. This guy is going to give me the same answer it did a minute ago, 7/3. This guy, I guess I should take it a little bit further, is going to get me 1/2 kx squared, evaluated at 1 and evaluated at 4. Okay, that's going to get me 16. Half of 16 is 8, so that's 8k. Take away 1/2 k, so 7.5 k. I believe it's 15 halves k times 7/3. do a little bit of cancelling. I think you get 35 halves K. Does that look good?
35 is 7 times 5. That's sometimes 15.
And I've cancelled the 3 with the 15 to get the 5. So I did a little cancelling as well.
Oh, okay. Derp.
Right, that's good. So keep track of me, you know, I make mistakes. So we got that guy, right? And now if you do m of x, it's going to be the integral from 1 to 4, the integral from 1 to 2, and it's going to be k. What else are we getting? K y times y squared. There we go. So that's going to be the integral from 1 to 4 of k. And then the integral from 1 to 2 of y cubed. And that guy just gets you 3k. And that guy gets you 1/4 y to the 4. So I've got 3k here. Okay, 2, 4 cancels 2 of them. So you get 4. 4 take away a quarter, leaves you 3 3/4, which is 15 quarters. So this time I get 45 quarters k. And that's my mx guy. Does that look good? So time to put these packages together and prove to you that you don't have a k in your answer. X bar is going to be y my over total mass. It's going to be 32 over 2k divided by 7k. The k's cancel out, and you've basically got 32 over 14, which gets me, I believe, 16 over 7. Y bar is going to be the moments around x over m. And I can't find my y bar. It's where's my mx? Where I need my mx, guys. Tell me what my
45 fourths k.
45. What again?
Fourths.
Okay, thank you. K's cancel, and I'm going to get 45 28ths, which I believe, can you do anything with that? 7 times 4? I don't think you can do anything with that. So it looks like the center of mass of this object is at 2 and a bit, comma, 1 and a bit. Does that seem reasonable? 2 and a bit, 1 and a bit. I guess it's in the shape, right? So it's reasonable. Are we comfortable with that based on the fact that I believe I got all the numbers in the right place?
I think you may have. I've been doing the thing, and I think you wrote what was the. I think the moment around y was supposed to be 35 over 2k instead of 32 over 2k.
35? Okay.
Yeah, and so if you do the math, if I did it correctly, the x bar should be 5 halves.
What, this one here?
Yeah.
And that ends up being eventually 5 halves. Okay. Which is 2 and a bit and 1 and a bit, which is, yeah. Well, if you imagine 3's in the middle, it's a little bit more this side than the other. Yeah, I could imagine that being reasonable. If I'd got an answer out here, wouldn't I be worried? Probably, yeah.
I think the crane would fall over.
I think something bad would happen and NASA wouldn't give me lots of money because of that.
Actually, I don't think it'd be a disaster. The crane just wouldn't pick anything up.
It would have issues physically. Okay. Now, where are we off to? Next one. The next question, I'm not actually going to do any of this stuff. I'm just going to set up the region D. Suppose you are given 0, 0, 2, 1, and 0, 3. And your density function, at least this time it doesn't have k's in it. But by the way, see if your density function did have a k in it, they always cancel out like they did in the last one, because your top answer is going to have so many k's and the total mass will have so many k's. Won't the k's cancel out? And so you're left with a number. So in this case, it doesn't matter, but the region D does. So I have a 0, 0, just here. I have a 2, 1, just here. And I have a 0, 2, 3, just here. And this actually looks very familiar. I don't know why. I think I've seen a shape like that before. Now, when you are setting up this region D here, question 4, you need to know the limits of integration. Great. Now, I can do this as little vertical rectangles scanning from x equals 0 to 2, or I could do it as horizontal rectangles scanning from y equals 0 to 3. But only one of them is actually going to work. Should I be scanning vertically, little rectangles, or should I be doing it horizontally? Which is the correct direction?
Vertically?
Okay, so that's correct. If you do it vertically, do you see that this shape consists of a top line and a bottom line? And that means this y value is going to be from some straight line to some other. The x's are the easy ones. They go from 0 to 2. Now, you want this guy here. If I continue him a little bit further, he passes through the origin and he's a slope of rise and run. He has a slope of a half. So that's y equals a half x. I continue this one a little bit further. So the top line, so y equals a half x, right, is at the bottom, right? That's him. Now the top one, it has a y-intercept of 3, and it's what, 2 boxes along and 2, so it's got a slope in -1. Are you happy about these limits of integration for that triangle? So if you were going to set it up, the first one, that's all that I'm going to do, you would be doing x equals 0 to x equals 2. Then you do from y equals 1/2 x to y equals 3 minus x of a density function, and you do the x's and then you do the y's. And you can imagine you've done integrals like that before. They're just time consuming. Would you agree?
Once you do the y first, because our first set of
Oh, I did the thing right. I didn't write the letters. So you're correct. You do the y first before you do the x's. And that's because y is here, x is there. Are we good with that? And then the moment around x and the moment around y. I feel like a physics professor today, and I don't like being a physics professor. Okay, we got what we got. 5 is really just the same idea, so I'm not doing that one. Well, I can set up 6, but I won't do much more than that. D is bounded by y equals x plus 2 and y equals x squared. And our density function looks like that. So you can do this in Desmos, but y equals x squared looks like this. I mean, it goes around here as well. And if you do y equals x plus 2, it's a straight line, so it goes something like that. What else are we doing? Oh, and actually, it does matter because it does curve around here. So the region D is the banana shape. Agreed? Straight line and x squared. So I need to figure out, we need to figure out the limits of integration. I mean, once you've done that, it just becomes another double integral like all the others. So vertical rectangles, scanning from left to right, horizontal rectangles. Where should they go with this?
I would do vertical rectangles, I think is what I would do.
Yeah. Why? You're right. Why would vertical rectangles be the best way to do this? Because
Because then you only have to describe with the linear function and the paraboloid.
if you went horizontal, wouldn't there be some places where it'd be one side of the green thing to the other side of the green thing? And that's not good. That's just not going to end well. I'm going to put this guy in, or these guys into Desmos. I want to show you, well, you probably know this, but I just want to show you anyway, that Desmos can be your friend, especially when the shapes start getting a little bit scary. So there is y equals x plus 2, and that's fine. And then I'll do Gesundheit, and then you do
Sorry.
y equals x squared. I'll move that around a little bit. Here we go. Now, if we're doing vertical rectangles, right, you'll start there, and isn't that x equals -1? And won't you finish up here at x equals 2? Do you see? So Desmos will tell you your start and finish value. So on the left, it's -1, and then on the right, you finish at 2. That just makes life a little bit easier. Plus, you get to see the thing, especially if you're careless and don't always do it. Question?
So if I'm on a test, like, because eventually we'll have a midterm, and
Mhm.
I said like, and I had to solve this problem, and I just said like, hey, I got my limits for my intersection points, my limits of integration, however I put it, got these from Desmos. Is that going to be acceptable, or do you want me to put in like?
No, you could be doing it on a TI-84 as well. All I would be able to see is this, because if I see this, I'll know what it is.
Okay,
if you
I just
screw
want to make
up-
sure.
Yeah, if you screw up here, the picture might help me understand what you did, because couldn't you simply just draw the line along and you use the correct values for your wrong line? Not that I've ever done a mistake in my life, so it's not like that would happen. But for some of you who are less perfect than me, that might happen. So it's a safety thing. If you don't do it, I'm fine. If it's right, if it's wrong, I have a bit of a problem.
I guess what I'm asking is, I would be okay if I just wrote those limits of integration through the picture and then said like intersection points found via Desmos or something, instead of writing out the algebra to actually find those intersection points.
Oh no, you don't need to do the algebra for the intersections. I totally agree. You either get it through Desmos or I mean, some of them, can't you tell it's 1 and -1 just by looking at the damn things? I mean, that's not where the problem should be, right? If forever you got a weird question, because who knows what WebAssign does, if these ended up being really ridiculous decimals, right? Yeah, I would know that what you did was -0.75 to plus 1.33 repair. Right? You'd be able to figure that out.
Okay.
So, x's, big to small, right? And which one goes on the right-hand side and which one of these two guys goes in the left?
Let's see, it would be x squared. It would be on the bottom.
Which one? Oh, x squared is on the bottom. Okay, agreed. So which end do you put x squared now?
The right there.
Here or here?
The side your pen is currently on.
Correct. And I forgot what the other one was called. X plus 2. There we go. Now, if you wanted to get the mass, then it would be the integral from x equals -1 to x equals 2. It would be the integral from y equals x squared to y equals x add 2. And then the density function would be this guy, and the y's and the x's. We comfortable? And since this is separable, I would probably break my integral into a k dx. Oh, take it back, take it back. Because these limits of integration are not numbers, I can't do what I just said. When I just have to do this long way. And it's laborious and kind of boring after a while, but you know you can get it, right? And this answer, I'm making this up, ends up being 4K. And then won't you stick an X in front of it to get the moments around Y? Won't you stick a Y in front of it to get the moments around X? And then off you go and you get your answer. Let's suppose you did this, just the mass one, not the other two. The other two could be negative. Can you imagine there's some shapes where the X coordinate was -2, right? I mean, I know it's not, but could you pretend that the answer was there? Wouldn't the X bar be a negative number? That's okay. Should this ever be negative?
No, you shouldn't have the negative mass.
Right, so if you ever get -20 out of this or -20K out of this, will you be really, really worried? Because that shouldn't happen. Now, X bar and Y bar are totally okay. In fact, can't X bar and Y bar be zeros? That just means the X coordinate is 0 or the Y coordinate is 0. Question.
Yeah. So for these types of problems where we have the equations,
Mhm.
Would it still be like the same process? We would still use the limits integration with the equations for
Yeah.
solving like my and mx and so forth.
Yes. So if you wanted to find, this is our equation for m, but let's suppose you wanted to find the moments around y. All you would do is stick an extra x in there. So you would be integrating kx cubed. And if you wanted to find m of x, the moment around x, wouldn't you stick an extra y in there? So you end up doing 3 integrals, which are very, very similar to each other. For instance, won't the limits of integration be identical? And one of them, that one is the mass. The guy with the y is the mx, and the guy with the x is the my. I can remember that's what it is. And then once you've done them, you just do some divisions and you are finished. Okay, I want to do one of these from start to finish because I've done a whole load of, just taking you to the, the beginnings, but not finishing. So let's see if I can find one. Where shall we go? Thing jumps around. Which one will I do? Yeah, this will do. So this is a version of question 7. And we know that D is y equals 1 minus x squared and y equals 0. So that's going to be our region D. And our density function is going to be 7ky. If you do 1 minus x squared, it looks like this. Great. Put it into decimals, that's what 1 minus x squared. Y equals 0 happens to be the x-axis. So the region they're talking about is this region here, right? And would you agree that we will do vertical rectangles to generate this one? So a typical rectangle would be something like this. So that would give me an x value that goes from -1 to 1. And the y value is 0 on the low side, and on the curve, 1 minus x squared on the high side. Are you comfortable about that as being the limits of integration that generate this fella, right? X goes from -1, scanning to 1. The y's, the rectangle, starts at 0 and climbs to the curve. So the mass is the integral from -1 to 1 for the x's, and from y equals 0 to the quadratic. And the function is the density function. I'm doing a dy followed by a dx. So this is going to be -1 to 1, and I'm going to give those guys the x. I did that again, didn't I? Limits integration can't do that. So back to what I should have been doing. If you integrate this, you add 1 to the power and divide by the new power, and you evaluate it at 0 and at 1 minus x squared. This guy is now going to be 7 upon 2 k 1 minus x squared, all squared, take away nothing. So it's going to be an integral from x equals -1 to x equals 1 of 7 over 2k 1 minus 2x squared plus x to the 4. Could probably pull this out as a constant term now. And integrate what's left. So on x, take away a 2/3 x cubed plus a 1/5 x to the 5, evaluated from -1 to +1. Okay, it's going to be 7 over 2k. You're going to get 1, take away 2/3 plus 1/5. I realize I'm not going to have time for this after all. Take away -1, -2/3 times -1 cubed plus 1/5 times -1 to the 5. See if I can at least get this bit done. 1 take away 2/3 add a 5th. It's not very pretty. 1 take away 2/3 add a 5th. And that ends up being 8/15. Take away -1, that ends up being plus 2/3. That ends up being take away a 5th. And turn that into a fraction. So 2 negatives make a positive.
Looks like you may have subtracted 15, not 1/5.
Ooh, darn it, I did, didn't I? Can I get that back? No, there we go. Okay. And okay, take away -8 is like adding 8/15, so kind of symmetry there. So you've got 7 over 2k times 16/15. They'll cancel a little bit, and you'll get what, 7/8, 56/15k. And then you have 2 more integrals that you'd have to do, and that is kind of us finished. Well, as long as you follow these instructions and you're more careful than I am, you will get the right answer. So say